So this is problem 77C from chapter 6. It asks to identify the elements and then to determine the number of unshared or unpaired electrons. And so to do this, you've got to look at sort of an orbital diagram. You're given the electron configuration, and we're only interested in the outer configuration 4s1 3d5. So it forms a lowest potential energy arrangement, which ends up being one in the 4s, one electron in the 4s sublevel, and then one each in the 3d sublevel. So a half-filled sublevel is more stable than a full sublevel and a partial. Right? If the 4s sublevel were filled up with 4s2 and then 3d4, that creates an unstable or a higher potential energy arrangement than 4s1 3d10. This is one of those exceptions that we talked about in the D block. And so the electrons don't know the Aufbau principle. They just go get pushed and pulled until they find the position of lowest potential energy. And so then Hund's rule says you got to have one in each orbital with the same spin until you can have two in any orbital. And so that's why there's one in each of the D orbitals and why they all have the same spin. Again, that's a low potential energy arrangement. That minimizes repulsion and maximizes attraction. And so you just count up the number of unpaired electrons. That simply means the number of orbitals that only have one electron in it. And that should be 6.